Okay, and we're going to finish up the basic functions that are roughly polynomial related by talking about power functions. Okay, we've seen these to an extent already. Basic ones have the form y is equal to k, just a constant, times x to the r power. X is our independent variable. R is just another real number. When we have r is equal to 1, that's just our basic linear function. We saw it in the form y is equal to mx. Okay. Notice that there is no y-intercept here, so the y-intercept is 0. It would have to go through the origin. Quadratic function, this would just be y is equal to ax squared. Okay, basic parabola going again through the origin. A cubic function, and so it says below to the left. Okay, so here's our basic cubic function. You'd have a constant here. We're saying k is equal to 1, but that's okay. So again, it would decrease as you go to the left and increase as you go to the right, passing through the origin. Okay, and if we continue to go down, we have now rational numbers for r. So if r is equal to 1/2, that's just the square root function. Okay, so the other half would be down here for the minus part, but we're only looking at the positive part. Okay, and then the cube root function would be very similar. It would kind of imagine the cubic function here reflected essentially about the line y is equal to x. They'd be inverses if you remember what that, or if you recall what that means. But in general, if we want to look at what properties a power function has when the exponent is greater than 0, there's kind of two things that we can say. If it goes through the origin. Okay, all of them we saw go through the origin. And then if k is greater than 0, as x increases, y increases. So k in this scenario, k was 1. As we increase in x, we also increase in y. Okay, and now keep in mind we said r can be any real number. Okay, so r could be negative, it could be 0. If r is 0, it's not too interesting. It just ends up being a horizontal line. So we won't focus on that too much. Now, when it's negative, some interesting things happen. When r is equal to -1, and that's right down here, we get this nice relationship here. This is called the reciprocal function. Some people know it as the inverse function. Inverse has kind of a sticky or a tricky definition, so I want to stay away from that. I'm going to define it as the reciprocal function, because if you compute y, to get y, you have to compute 1 over x, the reciprocal of x. And so if we put in 2, for example, we get out 1/2. Okay, and so we notice as we go to the right, we get closer to the x-axis, same as we go left, and as we get closer to 0, we go down to negative infinity on one side, up to positive infinity on the other side. For the inverse or the reciprocal square function down here, this is actually a picture from Wolfram Alpha. We actually see same sort of behavior towards the as we go out from x, hugging that axis, and then as we go up towards or as we get closer to 0, we get closer to the y-axis. So in general, if r is negative, we get two nice little properties. We actually get a vertical asymptote at 0. Okay, so again, vertical asymptote, just as a quick refresher, we'll see it in the next section or in the next lecture. But an asymptote essentially is a line that you get close to but never cross. Actually, I retract that statement. You can cross a horizontal asymptote, you can't cross a vertical asymptote. And then so we have a vertical asymptote on the y-axis and a horizontal asymptote on the x-axis. Okay, join us next for rational functions.